So, hello, welcome to the talk about JSON API. Just a quick disclaimer before I start the talk. It's obviously in English. Second disclaimer is this is a talk about the concrete specification that's called JSON API, not the generic concept as such. So I gave this talk a few times already, and sometimes there was some confusion where people were not aware that a specification exists with that name. They thought it was like about the concept of exposing and accepting JSON via an API as such. My name is Marco. I'm Marco W on Twitter. I will probably tweet the links to the slides later on. And I am the founder of SimpLabs. We're an engineering consultancy from Munich. We mainly deal with like distributed systems of all kinds, do architecture reviews and code reviews and consulting and training, all of those things. So if you have any demand for that, then talk to me later. So back to the topic. First of all, I have a quick intro. I probably don't actually need that as we're at an API conference here, but still, like maybe as a quick recap. So in 2017, the APIs are everywhere, obviously. So I guess many of you are integrating some sort of services, maybe microservice architecture or whatever. You might be integrating with third parties, which are the classic use cases for APIs, of course. But also in 2017, even if you're building a website or web app, you're probably dealing with a client-server architecture because the times of server-rendered websites are over, more or less. I guess most of you, if you deal with web apps at all, probably use something like these frameworks here or any other of the millions of other choices. And besides those web clients, you have native clients, of course, in mobile devices and on the desktop. And all of those client-server systems that we saw there have to transfer data between the client and the server, or maybe you have multiple systems that like, need to transfer data and basically synchronize resources between multiple points in like a network of systems. And usually nowadays, what most of us use to do that is accepting and exposing JSON via some sort of REST or REST-like interface. I guess things like SOAP, etc., are probably mostly dead by now. Is anybody using SOAP here? Okay, just two, but you're probably in the process of switching. Obviously, there's one exception. You might be using GraphQL now, and we'll get back to that later. But I guess most of us probably still use some sort of REST. So that use case seems to be like a sort of problem, right? Like your data format is JSON, your API endpoints like follow the REST principle, or at least are like maybe similar to it. So there seems to be no need for a spec that actually specifies how that has to look in detail, right? And then that leads some people to a reaction like this, like having a spec for JSON-based or JSON/REST-based APIs seems like over-engineering a very simple thing, and it might just not be needed. But the point is that there's actually a lot of variations of sending and receiving JSON data via a REST interface. And all of those many variations make it hard to reuse client and server code. You would often have to like rebuild serialization and deserialization code. Also, you have to relearn all the subtle differences between different APIs that you might be using or that you might be writing, and then somebody else has to learn like all those subtle differences. So let's look at a few examples here. This is from the GitHub API. We're reading the Rails repository resource here, and you see we get a plain hash that just has keys for all of the attributes. So it seems pretty simple. If we compare that to reading the Rails repository resource from the Travis API, you see that we have a root level key, and then that contains an object that has all the attributes. So it's a slight difference only, obviously, but it's still a difference. Often relations are handled very differently. So here we read the Rails repo again from GitHub, and you see that the owner relation is embedded in the main object that we receive from the API, and that's probably that is probably because it would often be needed, right? Like many clients that read the repository would probably need the owner as well, so it's convenient to have it embedded in the resource so you don't have to make a second request. But then if we compare this to Travis, then you see that the last build relation here is a reference. It only includes the ID, and that might be because it's rarely needed when the repository is read. And often those two kinds of references, or you might have more, like sometimes you have only like a part of a relation embedded in the record because that's what you need for a specific request. So it's like you would have a third variation. Really, and often those different ways of dealing with relations are mixed in the same API, because for that request it's convenient to have this relation embedded. For that request, all of the relations are just references because you never need them or something. And those two examples just are the very simple examples. Really, you might have more differences between different APIs, like are you using snake case or kebab case? Do you allow partial updates for resources so that you can like just send the attributes that you want to change, or do you always have to send the complete object for updates? How do you do filtering, like basically querying for resources with particular values for particular fields? Do you allow sparse field sets? If you do, how do you do it? So you have lots of options and options and options, and each time you set up a project, you have to choose one, right? Like for each of those options, you have to make a choice. Do you like use snake case or kebab case or snake case or whatever? And when you have to make choices, then people will have opinions, and sometimes those are strong opinions, and that often leads to fights then. And fights might take a lot of time and a lot of energy, but they're actually pointless, because the point with all these options is that you choose one, not so much which one you choose, because in the end it doesn't matter whether you use snake case or kebab case. It's the same thing. You just have to agree on one. And a less archaic metaphor for this is bike shedding problems. And the term bike shedding problem goes back to the observation of a guy who observed a committee that I think was tasked with coming up with plans for a nuclear power plant. And instead of doing, though, they spent a lot of time discussing the color of the bike shed that was next to the power plant, because there was a very simple to tackle problem and was easy to have opinions about that. Like, I think it should be red, no, I think it should be green. And then you discuss that for days, potentially, right? And that's why it's called bike shedding. Problems. And what JSON API wants to be, it wants to be your anti-bike shedding tool, because it already specifies all of those very simple choices, plus a few ones that are actually not so simple. And you also get that interoperability for free, of course, because if you have a server or really two systems that both implement JSON API correctly, they would be able to speak to each other without you having to to rewrite the serialization and deserialization code every time. A little side note here, you might have realized that the logo is not actually valid JSON because it misses the quotes. That's a little like Easter egg in the spec. It just looks better without the quotes, so a little joke. So let's look at the details of the spec. This is really only an overview. You can read up all the details on the website. It's JSONAPI.org. I think I had it on a previous slide, and you'll see the slides later. But obviously, of course, the point of having a standard is that you don't actually have to know all the details because you will be using a library, right? So if you want, you can read up on the details or just use a library that handles it all for you. So first of all, when looking at the details, just want to show this real quick. It's not so relevant. JSON API has its own media type that's registered with the IANA, so it's like kind of an official thing. So if you make a request with JSON API, you would send an accept header with that media type to signal that you expect a JSON API response. And then the response would look like this. You would get content type, same MIME type that signals that the response is a JSON API response, and then the payload. Obviously, the payload is the most interesting part about the spec, really. So what you see here is a resource object. And resource objects are really at the core of the spec. They represent individual resources. So if we look at the same response again, then we see we request an individual article here. So that's like assuming we have a blog example here, right? Like blog is always the best example. So we request an individual article with the ID 1 here, and then we get that response body that you see on the slide. Data is always the key for the primary response object, and in this case here, that's a resource object, which is this hash here. So first of all, you see there's a type and an ID that those are the required fields for a resource object. Because they are needed and also sufficient to uniquely identify an object, right? Like if you know the type and the ID, you can request it again. You can map two resources you might be getting from the server to the same thing in your client app. And then the attributes key contains all the attributes. So that like separating the attributes just makes everything a bit more structured, and also, of course, you could actually have an attribute that is called attributes because it can't conflict, right? Because it would be inside the attributes key of the resource object. So this is what a single what a response for a single resource object would look like. If we look at a collection response, then you see that it's pretty similar. So here we request all articles, leaving out the ID, of course, and then you see that the primary response is an array here, and that contains a number of resource objects, and each resource object has the same structure, of course, as on the previous slide for a single resource response. So, of course, attributes are relatively easy. What's usually a bit more complicated is relationships. So, of course, JSON API defines something for relationships as well. So here we have a bit of a larger resource object. The top is still the same, so you have type, ID, and attributes, and then next to attributes you have the relationships key, which contains the article's relationships in this case. And in this case here, it contains the relationship's contents directly. So you see that the article has an author relationship, and for that we include the relationship content in the response under the data key, and the content is basically all the data you need to identify the related object, which is type and ID, as we learned before. Type and ID, by the way, are called an identifier object versus a resource object, which is the whole thing. Identifier object is just combination of type and ID. So in this case, here the article has a relation to the author, and that's the author resources of type people has ID1, so you could make a request and get that. Obviously, with a response like that, you would have to make a request to get that, though, like a second request, which is obviously not very nice, because it might be or it would usually be a lot slower than having the relation right away. To solve that, JSON API allows or has a side loading mechanism that allows to put related resources in the same response body that you respond with for the primary resource of the request. So here we have the same example. The article with ID1 who has a relation to an author of type people with ID1, and then here you see that next to the primary response body we have an included array that contains all of the included resources that are like side loaded with the main resource in this case, and that included array just contains a list of regular resource objects. And of course, the relations of included resources could be included again. So you could have a whole object graph in this flat list here, right? Because all of the relations would just point to something that's identified by a type and ID, and then you can just go ahead and look that up in that included list, right? So that works for arbitrarily deep graphs, really. An alternative way of supporting relations is using hypermedia, where you just where you don't specify like what the relation's content is, but where the relation lives and where you can get the content. So here you see that for the author relation, there's no data, but a links object, and that contains links to get information on that relationship, kind of. So first of all, the self link is a link to the relationship itself, not its contents, but the relationship as such. So, for example, if you make a delete request to that endpoint, you would only delete the relation between the two resources, but leave the two resources that are related intact. While the second link related would actually get the relationship content, so that would get in this case, that would respond with a resource object for the people resource with ID1. And of course, you can also combine both ways of handling relationships. So you could have next to that links object, you could have a data object with the identifier objects for the relations, and of course you could also have a included resources. So basically, you can combine all three things together. So that is reading resources. But of course, in reality, we're not only reading, but we're usually doing some sort of CRUD, like create, read, update, delete. So let's look at how that works. So first of all, creation. In this case here, we are creating an article resource, and you see that obviously, because this is REST or REST-like, instead of making a GET request to the collection endpoint, we make a POST request to create a new resource. And in the request body looks the same as the response body that we saw in previous examples. So you have the data key to identify like the primary request object in that case, and that contains a resource object. Only difference being that we're leaving out the ID here, because normally that would be assigned by the server. You can use client-generated IDs with JSON API as well, but in most cases you would probably not want to do that. Like if you have a web front end, so like an Ember front end, for example, you would not want to use client-generated IDs because there's no benefit really. But you can. So that's the only case where leaving out the ID is allowed is when creating a record, but it's not required to leave it out. So you could send one. And also, one important thing to mention, in the future, you will also be allowed to have an included key here, so that you could, if, for example, you wanted to create the article and the author in one request, which is something that's very important for transactional behavior, of course, you will, in a future version of the spec, be allowed to have an included object for creation request as well. So you could use that to create the article and the author in one request, which would, like I said, allow transactional behavior, which right now is a bit hard with REST-based APIs. And then the response for this would look something like this. So first of all, you see the status code is 201 created, which signals that like successful server-side creation of the record. You also get a location header that has the location where you can then later read that created record again. And the response is again a standard resource object with the ID having been filled in by the server. And that is really the same response body you would get when making a GET request to that location endpoint, of course. It's just the normal single resource response for that resource. Let's look at updating. That's really simple, actually. You see we're making a patch request, and the request body is just the normal resource object again, so we're sending that to the server, and the response would then be this: true or false, no content, means a successful request but no content, because obviously when we send the full resource object and say we want the new state to be this, and that works successfully, there's no response necessary, as the request that we just send is now like the new state of that resource. So there's no response body necessary here. You are, though, allowed to send a response body if you have additional server logic. So you might imagine you have like an updated add attribute or so that the server sets when updating the resource. You would be allowed to have a response body, and I guess you will probably use a status code of just 200 then, and respond with a resource object for the update response for the update resource. Last thing I wanted to show is deletion. That's obviously really simple. Just make a delete request, and then the response looks like that. And I guess you can never have a response for deletion. I wouldn't be sure what that might look like. These are the basics really that you need for doing CRUD with JSON API, but there are also some more advanced things. First of all, you can let the client configure or encode in the request which relations it wants included in the response. For example, if we make a request like this, then that means we're reading the article with ID 1, and for the article we want to have the comments relation included, and for each comment we want to have the author included, which is obviously handy if the client can configure that based on what data needs it has for specific routes. And you can minimize requests with that, of course, instead of just having the server decide which resources are being side-loaded in which responses. Another feature that JSON API has is support for sparse field sets. Sparse field sets mean that you can specify which fields you want to have included in the resource for a particular resource, and that's obviously handy if you request a lot of data where it's actually relevant to leave out some fields to keep the response body smaller, or if you have resources with huge fields, like where you have like base 64 encoded binaries or whatever that you don't want to like load every time. You just need the name of that resource, maybe. So, for example, you could do something like this. You could read all the articles, include the author relation, and then say for the articles you only want to have the title and the body, and for the author, which is of type people, so you would say fields people, you only want to have the name. So that is quite handy sometimes, but you want to use that very carefully, and we'll see why that is later. It's much easier if you never use sparse field sets, because they can lead to all kinds of problems. But sometimes you need them. Also, there's more advanced features. We're not going through all of them here, because that would take too long. There's support for errors, so when you update or create a resource, there's like a particular format for the error responses that the server might respond with. There's a specification for how you do filtering. There's a specification for how you do pagination, which of course is similar to filtering, and you can read up all the details on the website. It's not so long. It might take you, I don't know, maybe 1 hour to read through the complete specification. It's relatively simple. But again, the point is that you don't actually have to know all the details, because you will be using libraries for that, and there's a whole list of client and server libraries on the JSON API website for lots of languages and frameworks. So there's probably something there for whatever language or framework you might be using. I wanted to address version numbers real quick again. Real quick as well, because obviously what's the spec worth if everybody implements a different version of it, right? Like you would end up in a situation when nothing is compatible again, because everybody expects or exposes a different version of the spec. JSON API's approach to that is pretty simple. So it's strictly additive. So anything that has been in the spec at any time is guaranteed to never be removed again. So basically what that means is that two systems that want to speak together can always figure out what the lowest common denominator is, and then use the feature set that version of the spec defines. Obviously, you wouldn't be able to leverage newer features, but you can still always find a way to talk together, which is really nice, of course. So that is the overview of JSON API. But I wanted to talk about another aspect, and we touched that briefly in the beginning. So many of you might be asking yourself, or maybe your neighbor ask you, why is he talking about REST? Nobody will be using REST in the next few years because we are all like super hyped up about GraphQL because it solves Facebook problems, so it probably solves my problem as well. I don't want to talk about GraphQL immediately. We'll get back to that later. First of all, I want to talk about why REST is still something that's really valuable. So first of all, a common problem with REST in the past was that it was often pretty slow because you had that problem of N+1 queries, right? Like you get a response that has references to 5 relations, and then you have to make like 5 more requests to load those relations. So we saw that side loading mechanism in JSON API already that solves that for a lot of use cases. But also because REST builds on HTTP and like all the feature set that HTTP provides, we get some performance benefits through that as well, actually. So for example, if we look at this request that reads an article with a particular ID again, and we assume that we read it for the first time here, then the response to that might look something like that. So basically same thing that we saw before, but now the server includes an E tag that basically is a token for that response, kind of an opaque token. And then when we read that same thing for the second time, we can include that token in the request and say only return the new thing again, or only return the full resource again if it has changed and doesn't match that token that I received earlier anymore. And then the response to that would just be 3 or 4 not modified. Just keep using what you have there. So that's a very nice mechanism for speeding up things. So with this, you don't have a response body, so no data is being transferred from the server to the client. Also, nothing has to be recomputed on the server side, which might be a very important thing, depending on the request and depending on how expensive it is to compute or look up the data that was requested there. And of course, the most important thing is that browsers support this out of the box. There's nothing you have to do. As soon as you include an E tag in the responses that you send, then browsers will actually make use of those E tags, even if you do XHR or fetch or whatever. You could even use a CDN in front of your API so that the request here might actually be fulfilled by some CDN's edge node that's maybe in the same city that I'm in or so. So you can really get incredible performance with leveraging HTTP performance mechanisms like E tags, or obviously you could use other caching headers as well. You could say the resource for the article with ID 1 is always valid for 5 days because we never change it anywhere or whatever. Or you might have other resources that are more or less safe to never change anyway. So you can leverage caching to great length, and when you combine that with CDNs, you can get incredible performance, really. Also, obviously, HTTP is not standing still. So we now have HTTP2, which is, I think, supported by 80% of the browsers or so. In many cases, that number might be much higher, depending on your actual user base. If you target mobile devices, the number is probably much higher because all the mobile browsers are usually much more modern than what you see on the desktop. Because you don't have huge companies that still use Windows XP or whatever. Everybody has a self-updating Chrome in their pocket, or iOS devices are very up to date usually and have modern browsers. So you can use many of the improvements that HTTP brings already. So, for example, making more parallel requests. So instead of limiting the number of parallel requests that a browser would make to 6, like it is with HTTP1, you can now have maybe hundreds of parallel requests. I'm not sure whether there's still a limit, but the limit is certainly going to be much higher than it was with HTTP1. You can also use server push. That is actually pretty interesting for APIs, I think. You can, if you have a client that does not specify relations to be included in a response, for example, you can just push them with the server to the client to get a similar benefit still. So all of those mechanisms can be used to make REST really fast. Another thing that I wanted to talk about, and that comes back a bit to the warning about sparse field sets that I gave earlier, is the fact that uniform resource representations facilitate data reuse. So what I mean with that is that if resources that you receive from your API are always guaranteed to be complete and always have the same shape, then that makes reusing those resources in the client or in the system that receives those resources much easier. Unless you use sparse field sets, in which case that is actually not really possible anymore, or much harder. So for example, if we have a block like this, so this is the list page that lists all the articles, and for each article it shows the title, obviously the text or some excerpt, and then the author's name. So with normal REST or with JSON API, you would probably make a request like this to render that. So you would have one request. The primary response object is the list of resource objects for the articles, and then alongside that you have the list of included resource objects, which would include all the authors. So basically, you have one request that loads all the data that you need to render the page. But of course, you have a bunch of fields that you don't actually need here, like the author bio or the URL of the profile picture, and so on. But then when the user that just loaded that index page moves on to the author page, where you actually need the author's profile picture URL and the author's bio, then you wouldn't have to make another request because you have that data already, right? So while you pay a bit more for the first request, you save the second request or the potential second request completely, which, depending on the real use case that you're looking at, might be a good thing, might be a bad thing. That is not a thing that is generally preferable, but in many cases, it will be much faster like this. So now when we contrast this with GraphQL, and the core concept of GraphQL obviously is that you only read specifically what you need, right? Because it lets you configure which exact data you want to have with a query language. So if we look at the same example again with GraphQL, and I'm not a GraphQL expert, but I guess it would probably look something like this. So here we don't need most of the author data, so we might be making a request like this. So we would say for the articles, I want to have ID, title, text, and then for each author, I only need the ID and the name. The name is displayed, and the ID is needed for building the link to the author page. So we certainly load less data here. But then same example, the user goes to the author page, so we need the rest of the data as well, so we would have to make a second request. We would have to make a second request to get that data. So here, instead of having one larger request, we have two smaller requests, which, like I said, for the example with REST, might be a good thing, might be a bad thing. It really depends on your use case. Just be aware that, that especially when you're targeting mobile, latency is the main problem. So the less requests you can make, it's usually better, right? Because actually transferring the response body is not as expensive as initiating a request from a mobile device usually. Also, this is not really about saying GraphQL is bad. You could have the same example with two different approaches with REST. Like first example is you include the author relation. Second example is you don't include the author relation and would have to make a second request. So it's more about comparing two approaches to loading data than like comparing two concrete things. But still, another thing that I want to say about GraphQL is that I think people are often not aware that GraphQL opens an endpoint that allows to perform queries against your data store, which can be pretty dangerous, not so much in terms of security, but in terms of you have to make sure that people don't make requests that bring your system down, because aggregations, for example, are often very expensive, and I have seen a lot of projects where running certain aggregations on certain tables would just bring the system to a stop, because tables are too big, or you don't have indices, and maybe you can't have indexes because of some constraint or whatever. So it's just something that you have to be aware of, and that brings me back to the point of people thinking that if something solves Facebook problems and probably solves mine as well, then you have to be aware of the fact that you are not in the same situation as Facebook. Facebook is one of the richest companies in the world, and probably nobody here is working for someone having the same possibilities. And also you don't have the same requirements and constraints, right? Which is really good. Like you might have, I don't know, a few thousand requests per minute or so, but in Facebook terms, that's probably still laughable, right? So adopting something that works for a huge company, it's certainly interesting and exciting, but it was built by a huge company for their needs. So, and you have very different needs usually. So to sum up, there's a great quote from Tom Dell. He says, GraphQL will replace REST in the same way that MongoDB replaced Postgres. So that is not to ditch GraphQL, but it's more about new things are very exciting, and we should keep exploring new approaches, but stable and well understood things that we already have been using for a long term are valuable. That does not mean we shouldn't progress. It's more that for certain things, stability and the fact that we do understand something quite well might be more valuable than switching to the next big hyped thing. So another quote by me then is that that in the end we all benefit from experimentation and from trying out new approaches. So it's a good thing. It's just you have to be aware of your situation, of your abilities, of your requirements, and have to decide whether one or the other is a good thing. But obviously, in the end, experimentation benefits everyone, and there will probably be a lot of benefit for REST by things that people experiment with in GraphQL. So my advice is, like I said, be excited about new things, but value the stable and well understood solutions. And JSON API is pretty nice. Obviously, we're using it all the time. It saves you a lot of time and energy. So yeah, I can only suggest to try it out. And that is it already. Thank you. And I assume we have time for questions. So if anyone has one? That's a good question. I'm not sure. I would have to read it up. It might support partial updates. I'm not actually sure. I would have to read that up, but you're right. Like usually, if you require complete updates, you would use put, and if you support partial updates, you would use patch. Like I said, would have to read up the details. Not sure. Yeah.
Could you talk a bit more about the implementation details? The workflow, how the developer will use the API spec?
Basically, you would, so for example, on the client side, or let me maybe take a step back. So JSON API comes from the Ember community, because Ember has a, does everybody know what Ember is? No? Too bad. Ember is something like Angular or React. It's pretty different from React, but it's used for similar things. So it's basically a framework for building single-page apps in the browser. And Ember has a data solution. So basically like an ORM that runs in the browser, and instead of connecting to a database, it connects to an HTTP API, right? And of course, if you build something like that, you have to define which backends you can talk to. And that's basically how JSON API evolved as like a formalization and specification of the kinds of APIs that Ember data supports. And then people realized it makes sense for a lot of more things as well. So on the client side, you would, for example, use Ember data, which basically encapsulates all of that serialization and deserialization in a serializer object, and then you might have like a JSON API serializer or your own serializer if you want to use something else, and then there's an adapter that makes requests and handles responses. And on the server side, you would usually be using a similar thing. So I think for Rails, active model serializers now supports JSON API, and there's like lots and lots and lots of other libraries for all languages, more or less, that support the serialization and deserialization. Of course, at some point, you will have to have a hook saying, I received a request with this to create that particular resource, and then the library on the server side at least will probably only do like the deserialization and then pass on the attributes to your code so you can create the actual record for that. I think in Rails and active model serializers, that's probably already solved because it just integrates with active model, but in other frameworks it might be different. Yep. More questions maybe? Or did it answer your question?
Yeah, it did. It's hard for me to think about what is the way to specify my concrete purpose of my API. Is it a common
I think I see what you mean. So basically, if you want to build your own API based on JSON API, you have to figure out what your resources are and what relations and what attributes those resources have, right? Because it's all about synchronizing resources. It's not about RPC or so, like allowing arbitrary remote calls with arguments or whatever. It's only about synchronizing resources. So the only thing that you really have to do is defining your resources and their shape and relation between them. And then the API is basically just mapping the CRUD actions to your else. I don't think JSON API defines what these URLs have to look like. I think you're free to choose, but usually you would be doing something like we had on the slide, like get articles for getting all, and then get articles /5 for getting the one with ID 5. And then as long as the request and response bodies look as defined as in the spec, you would have a valid JSON API implementation. More questions? Yeah. Sorry. No. Yeah, there's multiple approaches like this. No. I think comparing those would probably not be very exciting anyway, because they are quite similar. I think it's more exciting to compare really different approaches, like I did with REST and GraphQL, because they are like very different. Comparing those REST formats is you would probably only or mostly focus on smallish details, and I guess that's maybe not so exciting. But I don't really know any of those in detail to be able to compare them. Yeah.
Experience with combining JSON API with Swagger?
With what?
Swagger.
I don't know Swagger, to be honest.
Open API is also what is called Swagger. It's a way to document JSON APIs.
Oh, it's a documentation tool.
Yes, partially. You can also use it to generate clients for it.
Okay. I mean, if it so it would generate clients and server code based on like some. Okay. Yeah, I mean, so I would assume you can probably use it for this. Then, if your like Swagger documentation documents something that looks like this, then I assume it will work. But I have never used that. So, I mean, you don't need so much documentation for JSON API, really. The only documentation that you would need is defining what the resources are and what the relations between the resources are, and what the attributes of each resource are. Of course, if you know that, then of course you have to know the specific endpoints, but there's no or not a lot of documentation necessary, I think. Or I have never felt the need to have documentation for that. But yeah, never used Swagger, so I don't know, but it might work. More questions? Good, then. Sorry.
You mentioned that letting the client specify what he wants, which resources he wants to be included in the response, and which stuff can lead to problems.
Yeah. So basically, letting the client freely define which resources it wants included in the response would potentially lead to the same problem that we talked about with GraphQL, where you allow not arbitrary queries to be executed on your system, but pretty freely configurable queries. So if you include a number of levels of relations, or if the client would request to include a number or multiple like relation levels, that might lead to problems because it might just resolve in a huge response or so, or it might result in a huge database load, because you might have to like get millions of records or whatever. Sparse field sets is mostly problematic because you lose that resource reusability, or potentially lose the resource reusability on the client side, because if you, for example, if you have an article resource with ID 1 on the client, but you only have name, you only have ID and title, and not the body, because you didn't load that, because you used the sparse field sets mechanism, and then later you want to reuse that somewhere where you need the body, and then you would have to keep track of whether the body attribute in the resource you have on the client already is null, because you need to keep track of whether the body attribute in that resource you have on the client is null because it actually is null, or because you haven't loaded it yet. And that makes reuse much harder. And that's why I recommend to not use sparse field sets unless you absolutely have to. You might have a use case where you have a like really long table of things, and each of those things has one attribute that contains a base 64 encoded file or so. So you would probably not want to load that when loading the data for that very long table. But a mechanism to avoid that is also to move that file into a related resource and then just not load the related resource. And obviously, that does not mean you have to do the same separation on the server-side models, where you can like separate it in the API resource, but still keep the server-side model as it was before, of course. So that's like the potential problems that you might run into. Okay. Any other questions? No? Good. Then thanks.